Let's talk about entropy and enthalpy. Let's start with enthalpy. Enthalpy means energy, the total energy of a system. It's represented by the letter H. So if the energy, if heat is leaving, the enthalpy is decreasing. If heat is coming in, the enthalpy is increasing. Enthalpy, remember, is energy. So delta H or triangle H, when we say delta H, means the change in energy. So it can be exothermic or endothermic. If it's exothermic, the delta H will be negative. If it is endothermic, the delta H will be positive. Positive meaning energy had to be added in, negative meaning energy is being released. Sometimes the energy change is spontaneous. Systems in general favor a decrease in enthalpy or energy. So if I were to say to you, okay, you are going to have to do 5 problems for homework or 55 problems for homework, what would you pick? Most of you would say 5, less energy. Okay, so in general, systems favor less energy. So if the energy is decreasing, that's spontaneous. It can just happen. If we have to add energy in to increase the energy, that is not spontaneous. This is exothermic. So exothermic changes are spontaneous. Exothermic means it has a negative delta H. It's exothermic. Energy is leaving. It is spontaneous. Spontaneous, exothermic, negative delta H. If it is a positive delta H, it is endothermic, and it is not spontaneous. We have to add energy in to make it happen. Not spontaneous. We got to add energy in. So if energy is leaving, it is exothermic, being released, and it is a negative sign. If energy is being added in, it is a positive sign, and it is endothermic. So we're talking about H, enthalpy, energy. But don't worry, you don't actually even have to memorize that. Let me show you why. Well, you have this table, table I, for heats of reaction. So what you have to know is that heats of reaction means you're looking at delta H. And you kind of don't even have to remember that. See, look right here, delta H. It literally tells you this is your delta H table. So you can look at table I for delta H or the heats of reaction. And look at the bottom of the table right here. Look, a minus sign indicates an exothermic reaction. So literally, you don't even have to remember that. It tells you, but you have to remember the answer is at the bottom of the table. So if you're like, oh no, what does a negative sign mean? Oh, it's exothermic. But then you have to know the opposite of exothermic is endothermic. So anything that has a positive sign would be endothermic. So which reaction here would be endothermic? Well, remember from the bottom, if it is a positive sign, it is endothermic. So remember, a minus sign indicates exothermic. So positive would be endothermic. So we have this one and we have this one below that are endothermic. So which reaction releases less energy than the formation of CO2? So in this table, these are reactants, what you start with. These are what you end with, products. Start with reactants, end with products. So if I'm forming CO2, I'm looking for just CO2 on this side. Here we go. It's this reaction. This reaction releases negative, meaning it's exothermic. So it releases 393.5 kilojoules of heat. I want to find something that releases less than that. So I'm looking for a smaller number than negative 393.5, but it has to be negative still. It can't be positive. So right there, that's the right answer. Okay, so remember, a negative delta H means it's exothermic and it is spontaneous. A positive delta H is endothermic and it is not spontaneous. All right, now on to entropy. Entropy is the disorder in a system. So how disordered the particles are. Entropy increases as we move from solid to liquid to gas. Remember, in a solid, strong intermolecular forces, the particles are in like a rigid pattern. That's not a lot of disorder. So as we move from solid to liquid to gas, the entropy increases. Systems favor an increase in entropy. So you can see this shows low entropy. This is not disordered because these particles are not combined. This is high entropy. There's a lot of disorder. So I like to think about it like this. If you did nothing about it, what would your locker look like? If you did nothing about it, what would your room look like? Yeah, so systems, the universe, tends to favor greater disorder. More disorder. So systems favor an increase in entropy. Remember, systems favored a decrease in energy, but they will favor an increase in entropy. So which jar here shows high entropy, disorder? This one. Where does entropy start to increase? So where is the disorder increasing? In what image? Right here. Which box shows low entropy? Right here, high intermolecular forces, particles held close together. Which box shows high entropy? Gas, particles far apart, they can move around freely, weak intermolecular forces. And there you have it. That's entropy and enthalpy. Entropy disorder. Systems favor more entropy, more disorder. And enthalpy, energy. Systems favor less energy, less enthalpy. More entropy, less energy. That makes it spontaneous. More entropy, less energy. Spontaneous. Remember, delta H represents energy, the heat of reaction, and if it's negative, it's spontaneous. So I hope you learned something new today.